All right, ladies and gentlemen, welcome back to another round of information for pre-AP chemistry. This is Mr. Doolin, and I thank you. Thank you for tuning in. All right, so today what we're going to do is we're going to look at dimensional analysis. Dimensional analysis is something that we are going to use in chemistry for all kinds of conversions. All right, so we're going to use it for conversions in chemistry. We are going to use it for conversions in chemistry. Hopefully you took that hint and you wrote that down. All right, so dimensional analysis is also based on the fact that we can multiply anything by 1 without changing its value, right? You learned in math very early on that any number multiplied by 1 is the same number, and dimensional analysis uses that particular concept and allows us to convert from one thing to another without actually changing the conceptual value of the number itself, all right? Okay, so, but here's where it gets goofy because everybody can multiply any number by 1 because they can just rewrite a number. So the question really is what can 1 look like? Right? And here we go. There's all different ways it can look. We could put 4 over 4. We all know that equals 1. And we can put 65 over 65. We know that number is 1 as well. But let's really look at the concept of what's going on there. If we have a fraction and the numerator and the denominator are equal to each other, then the fraction simplifies to 1. Because not many of you would freak out if I put over here 4 equals to 4, right? We understand that. As long as I can put the two things equal to each other, if they're on top and bottom of a fraction, I know it simplifies to 1. Another non-stretch of your imagination is to put 65 is equal to 65. Everybody knows this, all right? Now, what if I come over here and I say that this is also equal to 1. And then I'm going to even try and confuse you more by saying 1 equals 2.54. And I'm going to say that is a true statement because I'm going to put units on my number. All right? So here we go. What are the units going to be? 1 inch equals 2.54 centimeters. That is a true statement, ladies and gentlemen. So when I look at my number up here, as long as I put those units in and I have this equality down here that is true, it makes this equal to 1. All right? Don't freak out because what you're going to get used to is putting units on your number. Units matter. I want you to put that really big in your notes, right across the middle of the page. Color it and highlight it. Units matter. Units matter. We're going to put units on just about every single number that we're going to write down between now and infinity. All right? Some common units that we deal with in chemistry right off the bat is grams, meters, liters, and moles, right? Here's a set of common units that we're going to deal with even in this semester and probably within the next week or so. As we'll start dealing with some of these common units. So grams, meters, liters, and moles. Units make a difference, ladies and gentlemen. Units make a difference because they allow us to still follow this dimensional analysis where the top and bottom of a fraction are equal to each other, so it simplifies to 1, and I can multiply it by anything, ladies and gentlemen. So there we go. All right, so another way that we might see this is if I put, let's say I've got a kilogram over a milligram, right? So again, 2 units. I want to turn these into what I'm going to call a conversion factor, right? This that we looked at up here, this is known as a conversion factor. And guess what the rule is for conversion factors? Is that they have to be able to simplify to 1. A conversion factor is something I'm going to use in my conversions, but it itself simplifies down to 1. So I want to turn this into a conversion factors. Well, if I look at my units, I've got kilo, and I'm just going to write, I'll write it out. Kilo, which I know is 10 to the third, and then I've got milli, which is 10 to the negative third. So look at the difference here, ladies and gentlemen. I've got a difference of 10 to the 6th. If I look at there, everybody sees positive 3, negative 3. There's a difference of 6. If you, in your head, think of a number line, you'd be able to count over 6 places to get from one to the other. So what I do here is I'm going to put 1 on the bigger unit, and then I'm going to put 1 times 10 to the 6th on the smaller unit. And so now this is equal to 1, and I have a conversion factor because I know I can come down here and I can write 1 kilogram is equal to 1 times 10 to the 6th milligram. That's a true statement, and that follows along with what we need to do with the dimensional analysis to make a conversion factor. Our conversion factors need to equal to 1. All right, so let's do another one. Let's look at a decagram and a decigram, right? So a decagram is actually, if I look at that, is 10 to the 1st. A decigram is 10 to the negative 1st. So I've got a difference here of 10 to the 2nd. All right. And so what I would do, which is a bigger unit, the decagram is a bigger unit, and 1 times 10 to the 2nd for the decigram. Right? Not anything crazy. Where this also starts to look is the bigger unit does not always have to go on top. Right? It doesn't matter the way I write this, so I could also write it as 1 times 10 to the 2nd decigram over 1 decagram. These are both the same. They're both equal to 1, ladies and gentlemen. And so as long as they are equal to each other, I can put them on top and bottom of each other, and I can multiply them by anything else without changing the value. Okay? So now, how are we going to really use this? I said at the beginning we're going to use it for conversions. And so let's take a look at a couple. And we're going to do a lot of these practices in class, so don't freak out. What if I want 23 inches and I want to know how many centimeters that's actually equal to? So what I'm going to do is I'm going to take 23 inches, I'm going to multiply it by a conversion factor because I don't want to change the actual value of the number. I still want it to represent that amount. All right, and so my conversion factor here, what I'm going to do is I'm going to take this unit because I want to cancel it out, and I'm going to put it diagonally. Now, that's another kind of math fact that I'm pulling in from your previous years, that when I have two things that are diagonal from each other, I can simplify them, right? And remember what we talked about when we were doing manipulating variables, this thing will actually simplify itself out to 1, right, at the end of the day. And so I'm going to go ahead and write it back in there, though, and then I'm going to put centimeters on top because that's what I want. Now here, can I make something? I'm trying to make a conversion factor here. If I have something in centimeters, can I make it equal to inches? Well, yeah, we looked at this earlier. 1 inch is equal to 2.54 centimeters, right? And so what I would do is I'd come down here and I would put 1 for my centimeters and 2.54, or I'm sorry, 1 for my inch and 2.54 for my centimeters. Right, now I have a conversion factor here that is equal to 1, so I'm not multiplying this by anything other than 1. And so now my inches actually cancel out. They simplify. My units left are centimeters, right, here on top. And then I'm going to do 23 times 2.54, which is actually 58.42. And so 23 inches is actually equal to 58.42 centimeters. All right? I'm going to do some more here with you, okay? So keep following along. The more you do this, the more sense it will make. So 2.54 kilograms. I want to know how many grams that's actually equal to. So again, I'm going to start with the number I'm trying to convert. So 2.54, and that was kilograms, wasn't it? And then I'm going to multiply it by a conversion factor here. So again, I'm trying to get off of there. I'm trying to get rid of kilograms, so I'm going to put that diagonally, and I want it to go 2 grams. Well, can I relate those two? The answer is yes, right? Again, I'm going to look at kilo, which is 10 to the 3rd. Grams is a base unit, which is 10 to the 0, right? And so now I'm looking at this. It's a difference of 10 to the 3. Well, where does the 10 to the 3 go? It goes up top. 1 times 10 to the 3rd. 1 goes for your larger unit. And this works when you're in that metric prefix system. right? And all you're doing is converting from one prefix to another. All right, that's when I'm actually going to set up something like this over here. So you probably want to make a note there and say, I'm going to be able to use that little trick there to figure out what number to use when I'm trying to convert within a metric prefix system. All right, and so all I'm going to do now, kilograms actually simplifies out. So it's 2.54 times 1 times 10 to the third. So I've got 2,540 grams. All right. So again, nothing crazy, and I'm not dividing by 1 here because I don't need to divide anything by 1. All right, and then I'm going to go ahead and erase this just because I need the room. You don't have to erase it. So here we go. Last example I'm going to do with you here. So I've got 204.5 milliliters. I want to know how many liters that's equal to. And so again, I'm going to start with the number I want to convert. I'm going to set up a conversion factor and put milliliters. I'm going to put them diagonal here, and so liters up on top. So again, I see that this was within the metric prefix system. So I've got milli, which is 10 to the negative third. I've got a base unit, which is 10 to the 0. So again, that's a difference of 10 to the third. My larger unit's going to be 1. My smaller unit is 1 times 10 to the third. So in this particular case, I'm actually going to divide this out, right? Milliliters still cancels, right? It still simplifies, but it's 204.5 times 1 and then divided by 1 times 10 to the third. And I'll show you how to put that into the calculator in class, because most of you, if you try this on your calculator, you may get it wrong if you type it in incorrectly. And so I've got 0.2054 liters when I actually do that division correctly. All right. So these would be my numbers. Notice I didn't do any significant figures on these numbers. I am not worried about significant figures with you right now with dimensional analysis. I need you to get the concept of this down and be able to convert from one thing to another. Then when we're comfortable with that, I'll slap significant figures back in your lap and we can start doing sig figs, okay? All right, so hopefully you wrote down any questions you had. We will answer those in class. We will do some practice with this in class. Please make sure you try to understand this as best you can before you get to class, because the better understanding that you've got when you hit that class door, the better you're going to do. All right, this is Mr. Doolin. Peace out. I'll see you in class.